Hello friends, this is today POTD problem, which is easy one. Max distance between same elements. So we have an array base and which having occurrences of two elements. We have to find the distance, maximum distance between the occurrences of two elements. Okay, right. So for suppose for this array, so what uh, what we have to do. So there are two elements in this area. One is one, two, and the occurrences of we have to know the first occurrences and the second occurrences. For the element one, the first occurrences is at index 0, and the second occurrence. That means actually this is the last occurrence. Last occurrences of one is actually 1, 2, 3, 4, and 5. So 5. And for second element, the first occurrence of second element is 2 and the last occurrence of second element is 4. So and we have to find the maximum distance between them. That means 0 minus 5 is equal to 5, and actually we have to apply mod for that, and 2 minus 4 is 2. So among this the maximum distance is 5, so we have to return 5. So that's why the answer is 5 here. Okay, so what is the brute force approach? So for every element in the array, we have to know the first and last occurrences of that element. So in order to know the first occurrence of the element, we have to use a for loop, which iterating from index 0 to the n minus 1, n minus 1. So like end of the array. And for uh, knowing the last occurrences of that element, so we have to use again another for loop, right? So but it starts from end of the array and to the index 0. So as for this element, uh, so the starting index is 0, and so for this element we have to find the ending index. So for that we have to write a and for loop which starts from the end of the array, and we have to break where we are getting that element. So as I'm getting the element here, so I have to break the process, but before that I have to know its index, and its index is 5. So and 0 5, so I have noted the distance is 5 there, and then we have to move the iterator. So for this element also, uh, the index is 1, and we have to find the index find that element from the end of the array in order to know the last occurrences of that element, so which is 5, and 1 minus 5, the distance is 4, and among 4 and 5 the maximum value is 5. So we don't need to change, like we are not allowed to change the maximum value, and we have to increment the iterator. Now it will point to 2, and the first occurrences of 2 is so 0 1 2 2, and the last occurrences of 2 is 4. So 2 minus 4, the index is the maximum distance is 2, and among 2 and 5 the maximum value is 5. So we don't need to update the maximum value for 5 for m, and we have to increment. So now this time the value is 2, and which its index is 3, and so when we are iterating from the back for the last occurrences of that element, then the index is 4, and 4 minus 3, now the difference is 1. So 1 and 5, so the maximum value is 5, so it's constant. So finally we have to return that array, right, after iteration of the array completed, right? So which is 5. So this is just the brute force approach, right? So we have to find the first occurrence of the element, and what we need the last occurrences of that element. For that we have to use a for loop, and yeah, this is the brute force approach. But there is a problem here, so you can see that yourself. It it gives the right answer, but it will give the TLE, right? So exactly at the 105th test case, I'm getting the time limit exceeded. So why? Because it uses the big of n squared time complexity, and what we need here, we need a time complexity big of n. So for this conditions, we have to use the data structure, and to satisfy these needs, we can use set or map. Both are okay, but I'm choosing map. Why? Because it's easy to note the frequencies and the element, right? So let us take that array again. 1 1 2 2 2 1. So what I'm saying, I'm using map here, right? And so uh, for each element, and we have to know its frequency. Generally, we don't need to save its frequency. We have to save its index, which is like a starting index, right? Okay, so 0, 1, 2, 3, 4. So these are all the indices of the array, right? So now when we are iterating, we get element 1. So we have to check whether that element is present inside the map. As it is not present, we have to put that element inside the map along with its starting index, which is 0. Now we have to again iterate. So now 1. So is 1 is present inside the map as. So then continue the process. No need to put that element again into the map, right? And now the element is 2. Is 2 is present inside the map. Is 2 is present inside the map? No. So then we have to put that element into the map along with its starting index, now is 2. It is 2 again, so as map contains, you don't put that element into the map, you don't update the map. So here also 2 and here also 1. Now map contains the starting indexes of that element. So for not to know the ending indexes, we have used the for loop again, that which gives the work and time complexity, right? So for that, we have to use that map again, like it stores the element and it stores the ending indexes. Now, so now we have to iterate from the backward, and then we are getting 1. So 1 is present inside the map now. So we have to put that element and along with its index. Now the index is 1. Now, so we have to increment the data, right? Now the element is 2. Is 2 is present inside the map now. So we have to put that element along with its index, right? Now the element is 2. As 2 is present, don't change the map. Now it is 2 again and it is 1 again, as 1 is already present inside this map. So don't change that map. Okay. So now what we have starting indexes and the ending indexes. So from these two, we have to iterate any one of the map, and we have to get the ending index of the another map for that same element, right? Uh, can I say, so for this element, for the first element, we have to check whether that element is present inside this map, and if it is, we have to get that index. Now 0 minus 5, so which gives 4 5 as distance, right? And for 2, so 2 minus 4, which gives 2. So among between these two, the greatest value is 5, so we have to return 5. So, but here the space complexity is actually big of 2n, and we can reduce on it. We can make it into big of n by using only single map. So instead of performing the calculation part outside of the map, we can perform this calculation operation inside the insertion, like like this is the map, and as it stores the element index and its starting index, which is 0. Now when I'm getting the that element again inside the map, Then what I have to do, I have to find the distance between the current element like 1 1 or 2 2 2 1, right? So 0 1 2 3 4, as this is a array, right? So I'm storing this element inside the map because it is not present inside the map. And for now the element is 1 as it is present inside the map. As it is present inside the map, what we have to do, we have to find the distance between these current index of that element and the element which is already present inside the map, and the distance is actually 1 minus 0. Now the distance is 1, and we have to store that into a max variable. So no, so max contains 1. Now we have to increment our iterator, which is 0.222. So 2 is present inside the map. Now put the 2 along with its starting there. Now increment the iterator. 2 is present inside the map. As it is present. So whenever when I'm like when the map contains that element, then we have to find the distance, current distance between the indexes of the element which is map contains and the string contains, and the distance is 3 minus 2, which is 1 again. So 1 1, there is no need to change the map, right? And now the increment the data, now the value is 2. So 4, as the map contains the starting index which is 2, so 4 minus 2. So now the value is 2, and among 1 and 2 the greatest value is 2, so put this element inside the max variable. And now the value is 1 as 1 contains the map. So now we have to find the distance between them, which is 5 minus 5 minus 0. Now the value is 5. So among 2, like between 2 and 5, the greatest value is 5, right? So we have to now keep this value inside the max variable, and now increment the iterator. As it points the end of the array, we have to return the max variable. And the space complexity, and that like the space complexity is big of n, and the time complexity is also big of n, right? So let us see the code for that approach. So this is the map. I am using the unordered map. Like we can also use the map ordered map, but uh, it gives the time complexity of big of n for finding an element, but this unordered map gives the big of 1, so for finding the element. So that's why I'm using this, and this is the max variable. And so I have to iterate over the array, and when I am the map does not contain the whenever the map does not contains the current element of the array, just put that element along with its index inside the map. Then okay, then after, if the element is actually find inside the map, then uh, find the distance between the indices which the map hold and the current indexes, and store only the maximum index inside the max variable, right? So if for loop execution is completed, then just return the value, right? Then the max value, which is successfully accepted. I hope you understand this video. If you find it helpful, please like it.